In this lesson, we are going to look into the rate of change of a linear function. And so remember, when we talked about linear functions, we discussed a linear function rate of change as constant, meaning between any 2 points on the line, the increase in the vertical distance between the 2 points as compared to the increase in the horizontal distance between the 2 points is the same for the entire line. So it doesn't matter what 2 points you choose, the rate of change is consistent along the whole line. It's kind of like the stairs. The height of each stair as compared to the width of each stair is the same or in proportion, right? So if I go over 2, up 3, this one would be going over 2, up 3. Or if I had one big stair in the same proportion, it would be over 4, up 6. This rate of change describes how steep a line is. How steep a line is the slope of the line. And today we're going to focus only on the slope of the line, just like on a ski run, right? If we have a large vertical height as compared to horizontal, we have a very large number, right? 8 as compared to 1. The steepness would be a factor 8, 8 divided by 1. Whereas in a green run, if we had a smaller vertical as compared to horizontal, 4 as compared to 4, right, then it would be a steepness factor 4 divided by 4, which is 1. So the greater the number, when you take the vertical height as compared to the horizontal or divided by, the greater the number, the steeper the line. And that is the slope of the line. Now there's 4 types of slopes we're going to talk about. The number tells us how steep it is. But the sign, the positive or negative sign, tells us the direction. Okay? So if a line, looking from the left side of our graph and looking at it, if the line is getting larger, higher, or going up, then it has a positive slope. If the line is falling left to right, it has a negative slope, right? It doesn't tell us how steep the line is. The negative and positive only tells us the direction, if it's going up over time or if it's going down over time. The other type of slope is if we have a horizontal line. Remember, all horizontal lines have no rate of change, therefore the slope is 0. Vertical lines, which we haven't talked about yet, vertical lines, think about a ski slope that has a vertical run. That would be called a cliff, wouldn't it? Well, we wouldn't be skiing that, right? You'd be free-falling it. So a vertical line has undefined slope. And I'll explain why we use the word undefined later on in this lesson. But we understand that there's 4 types of slope. Okay? There's positive slope, there's negative slope. When we give you a value for these slopes, it tells us how steep the line is. Horizontal lines have 0 slope and vertical lines have undefined slope. A common way to describe slope is using the statement rise over run, because when you have a line and we make the stair, we talk about that vertical height being the rise, and we talk about that horizontal distance being the run. So rise divided by run is slope. That's how we calculate the value. So you just have to find 2 points on your line, 2 clear points on your line. It doesn't matter which 2 points you pick. Then you create, and it doesn't matter if your stair goes below or your stair goes above. You create that horizontal and vertical distance between the 2 points. Now I calculate or count the vertical height, 1, 2, 3, 4, 5, 6, and 1, 2, 3 for the horizontal. And so the definition of slope would be our rise over our run, and then we would reduce this fraction. If the denominator goes in evenly, we would divide. We leave our fraction as an integer or fraction in lowest terms. I know this slope is positive because we are rising left to right. This slope, I would find 2 points. Doesn't matter which 2 points. I would take my rise as compared to my run. I get 2 over 1. 2 divided by 1 is 2. However, be careful, this line is falling left to right, so I have to remember to put my negative sign. That has negative slope. Which line is steeper? Is A steeper than B, or is B steeper than A? The answer is they are both the same steepness because they both have a value of 2 for their slope. So they're exactly the same steepness. However, because of the sign, a positive slope it's rising left to right and a negative slope it's falling left to right. If we look at C, I would take 2 clear points, create my horizontal and vertical distance, 1, 2, 3, 4, 5, 6 as compared to 4. My slope would be 6 over 4. I'm going to remember to put a negative because it's falling, but then you always make sure you reduce your slope to lowest terms. Leave it in proper. Do not change it to a decimal. Do not change it to a mixed fraction. Same thing over here. Oops, vertical line. Vertical lines have undefined slope. Here we have a positive slope. Pick 2 clear points. Count out our rise over run. 1, 2, 3, 4, 5, 6 as compared to 2. 6 as compared to 2 becomes 3. Horizontal lines have 0 slope. Okay, so we should be able to talk about the slope of a line. Reminder, slope is a characteristic property of the line. It describes the steepness. It does not describe where the line falls. It only describes how steep it is or how to get from one point on the line to the other point on a line. So if I want to graph a line with a particular slope, I would need to give you a point on the slope. So you would always have to count from a point on the line, a point on the slope, point on the line. You'd always have to count from a point on the line to another point on the line using the slope property. So let's plot -1, 0, left 1, 0 up. And from that point, I'm going to go, rise is up 3, since it's positive. Positive means up. Right, 5. To the right is positive, to the left is negative for run. So since they're both positive, I'm going to go up 3, right 5. And there's not just 2 points on a line, there's infinite, right? I can keep going up 3, right 5, or again, if you have positive slope, reminder, if I make both of them negative, I have positive slope again, because a negative divided by a negative is a positive. So what I could also do from this point is I could go down 3, left 5, because 2 negatives also provide you with positive slope. And then you have a nice, you can use your straight edge line going all the way through those points with that slope. Okay, let's try another one. 2, 3 is a location. X is 2, Y is 3. That is a location on my graph. That is not slope. Slope tells me how to get to other points on a particular line with that constant rate of change. It means to go up 1 over 4. That means, for example, after 4 seconds, the increase in height of my water in my container is 1, right? So 4 seconds have passed, I now have 1 extra height, right? If I go backwards in time, if I go back 4 seconds in time, I've lost height, right? So if you go back for both, you also have that same linear function that relates the two quantities. All right. If it goes to the origin is simply where the two axes intersect at 0, 0. So that's a point on my line. See how the other ones did not go through the origin? This one does. So whenever you have a negative slope, you need to assign that negative to either the numerator or the denominator. A negative slope is either -3 over 2 or 3 over -2, right? You couldn't put a negative on both because then it would be a positive slope. So from your point, you would go, let's look at the first one. Down 3, and then right 2, because 2 is positive. Right 2, whoops. Down 3, right 2. And let's count that out again. Or I could have gone up 3, right? Because up 3, left 2 would get me back. Doing the opposite of both. And then you would draw your line through all those points. Okay, let's try one more. 4, -2. If you have a slope that's just a single number, and a slope needs to have two properties. It has to have a rise and it has to have a run. You always need to take your slope and create a fraction out of it. So if it's -3, I'd put it over 1. So that means down 3, right 1. Down 3, right 1. Or I could have had it as 3 over -1. Up 3, left 1, and so on, right? And so we can see that's quite a steep line because 3 is greater than 3 divided by 2, so it's a steeper line. The negative just simply tells us the direction. So if I gave you slope something like, I don't know, let's say 0.25, I would change that to a fraction, 1 over 4, right? If I gave you a slope like 0.7, I'd change that to a fraction. I could change it to 0.7 over 1, but it's hard to count up 0.7 and over 1, so I would prefer it being like 7 over 10, using integer values to count. So that means up 7, right 10. It's the same as 0.7 over 1, but easier to count. So the other way we can calculate slope, if not provided the graph, if we're only provided 2 points, but we don't have the graph, is to use a formula. And let's figure out what formula would help us. So let's take a look and derive a formula over here for finding the slope between 2 points. So for example, this is 6, 9, and this is 2, 3, going through these 2 points. Then we know the slope is that vertical distance as compared to the horizontal distance. The vertical distance here, which is 1, 2, 3, 4, 5, 6, how do I get that from just looking at my points? Well, vertical comes from how far up you go. First person, let's pretend this is a first person. The first person went right 2, up 3. The second person went right 6, up 9. So the up part is the 3 and the 9. So the person who went up 9 went up higher. How much higher? Well, they went 9 minus 3 units higher to get the difference in 6. Well, if we just looked at the going right, the first person went right 2, the second person went right 6. So the difference between how far right they went, or their horizontal distance, is the person who went further subtract the person who did not go further, who went less, and you would get the distance of 4, right? So you take this number, subtract this number, the y's, to get the vertical difference, and you subtract the x's to get the horizontal distance. So we got the idea. So now what I'm going to do is, instead of using these points named, I'm going to use generic points. I'm going to call this point x and y, and I'm going to call this point x and y. They're just generic, but they're different points, so I have to label them even further. I'm going to call this my first point down here, so I'm going to call it x1, y1. I'm going to call this my second point, or x2, y2. Right, so that's my second point and my first point. So how did I create and find this vertical distance? Well, I took this second y and I subtracted the first y. And how did I find this horizontal distance between these 2 points? Well, then I took my second x and I subtracted my first x. And so that's part of the formula for calculating slope. Once you have those numbers, you now just take your rise and divide it by your run. So over here, let's write our formula out. Our slope is calculated as the second y subtract the first y all over the second x. Those are just little subscripts, they're not powers, they're just telling me it's the second point's x. Subtract the first point's x, right? So given these 2 points, given 2 points, and the 2 points are x1, y1, and x2, y2. So let's practice using that formula to calculate slope. So looking down here, just be careful. Remember, slope is calculated by subtracting, not adding. Most common mistakes are made when people start adding because they see all these negatives and it gets confusing. So our slope is going to be, now which one do I choose to be the first point and the second point? Well, it doesn't matter. You get to choose, but you have to make sure you've decided. So I'm going to choose that first one to be the first points and the second one to be the second. It's just easiest that way. Now I'm going to take the second y, Subtract. Make sure you write that minus sign, otherwise you'll mess yourself up. Subtract the first y. And again, I'm starting with the y's, not the x's. And then I'm going to take the second x, and I'm going to write my subtraction sign, and I'm subtracting the first x. And you can see why writing that subtraction sign matters. Some people write this as 3 minus 5, but it's not. It's 3 minus negative 5. Right? So be careful there. So now I just simplified. Negative 1 minus 4 is negative 5, and subtracting a negative is adding, so I get 8. I leave my slope in lowest terms. Let's try another one. A lot of times I'm going to use little m for slope. We'll see that next chapter when we talk about the equation of a line. So I'm going to start using little m for slope. So I'm going to take the second y, subtract the first y, all over the second x, subtract the first x. And this time I'm going to get negative 9 over positive 8. So now we're calculating the slope of a line given 2 points without having to graph it. I now know if I graph this line, it's going to be negative slope, so it's falling left to right because I can see the slope is negative, and I know the height will be 9 and the run will be 8. I know that property. Trying this one over here, I'm going to get my slope to be the second y, subtract the first y, all over the second x, subtract the first x. And then this one, I get 0 in the denominator. In other words, there is no run. What kind of a line has no run? Vertical lines have no run. So also, we know in mathematics that when you divide by 0, it's an undefined operation. So an undefined operation is not possible. So whenever you get 0 in the denominator, we say it's an undefined operation or undefined slope. That's why vertical lines have undefined slope, because you end up with 0 in a denominator, which is not a defined operation in mathematics. And then this one here, I'm going to get negative 2, subtract negative 2, all over negative 3, subtract 4. And this time I'm going to get 0 over negative 7. And when I get 0 in the numerator, it means I have no rise. Right? If I have no rise, that means I have a horizontal line or I have 0 slope. Okay? So if you get 0 in the denominator, it's undefined slope. If I get 0 in the numerator, it's 0 slope. If I just gave you a table of values and asked for the slope, well, a table of values is really just a bunch of ordered pairs, right? I now have lots of information to find the slope. And I can do this a few different ways, actually. If I could go ahead and use my formula, or I could just say, well, I know that I can figure out what am I going up by in y here as compared to x, right? So I can see my slope is going to be my change in y over my change in x. That's one way I can do it, like we learned earlier. Or I can just take any 2 points. If I know this as a linear relationship, then I know there's a constant rate of change, and therefore I can just use my slope formula. My slope is going to be my second y, subtract my first y, all over my second x, subtract first, and I get 12 over 2. Oh, again, 6. So I can find my rate of change is 6. My y's go up by 6 when my x's go up by 1. That's my rate of change. The last little bit we're going to talk about is what happens if I give you the slope and in the 2 coordinates, xy pairs, one of your coordinates is missing. Well, this is me giving you the answer to a formula and one piece of the formula is missing. So this is when you're going to use algebra. Whenever you give the answer to the formula, you have to work backwards. You're going to use algebra. So here, let's practice this. I'm going to take my second y, subtract my first y, all over my second x, subtract my first x. And that equals 5 over 8, my slope. 33 minus 1, I can clean that up to be 32. So whenever you have proportional reasoning in mathematics, a fraction equals a fraction, we can cross multiply. You take the 8 and you multiply it by the a minus 2. You make that equal to the 5 multiplied by the 32. And then we'll use our algebra skills. I can divide both sides by 8 first, or I could use my distributive law. Add 16 to both sides. Divide, whoops, that's supposed to be an equal sign. Divide both sides by 8. And you now know A is 22. Okay, so all we're doing is we're using our formula for slope, plugging everything in, and then using algebra to solve. So I can do the same thing here. I'd take my second y, subtract my first y, all over my second x, subtract, just write it, say it as you write it, then you make less mistakes. Subtract your first x, right? So you write the whole thing, subtract that. And we know the answer. Whenever you have a negative in a fraction, I write the negative either with the numerator or denominator. I assign it one of the two. Don't leave it out front, so when you cross multiply, the negative goes with one of them. Before I cross multiply, I'm going to clean this up. I'm going to change the subtract negative to just adding, and I'm going to collect like terms. 4 minus 2 is 2. So now it's all cleaned up. I can go ahead and cross multiply. It doesn't matter which one you do first. I can go the 2 times the n plus 3 first and make that equal to the negative 3 multiplied by the n plus 2. And let's get that distributive law going. Now I have an n on both sides, so now I have to get all my n's to one side. So I'm going to move the negative 3n over, and I'm going to move this positive 6 over. So this negative 6 is still there. Collect like terms, and divide both sides by 5. And so now I know n is negative 2.4. So today we learned how to calculate the actual value for slope or constant rate of change using either a graph, rise over run, or we learned how to use it with the formula, y2 minus y1 over x2 minus x1.